Alright, so let's do this one more time. This time we've got this big, hairy, awful-looking polynomial p of x, which is a fifth-degree polynomial, and we're asked to find all the zeros given that 3 plus I is a 0. Well, what does that mean to me? Well, let's go back to our zeros theorem. Our complex pair theorem states that if we have only real coefficients, 1, -8, 13, 52, -198, and 180 are all real coefficients, and if x equals 3 plus I is a 0, then the complex conjugate must also be a 0. So 3 minus I. So what I do is I take these two zeros and I rewrite them as factors. So in other words, x minus the quantity 3 plus I, and x minus the quantity 3 minus I. So now when I multiply these things together, I'm going to get a binomial, I'm going to get a second degree polynomial that I can divide into this fifth degree polynomial and help me, hopefully, be able to find the rest of the zeros fairly easily, at least I hope. So let's see. X times x by our FOIL method is x squared. X times negative 3 minus I, so that's minus x times 3 minus I, minus x times 3 plus I, plus, at the end, negative times negative, the quantity 3 plus I times 3 minus I. Well, let's simplify this a little bit more. X squared minus 3x plus x times I. Distribute the negative along with the x there. Minus 3x minus 3i. Sorry, minus xi, pardon me, there we go. Plus, and let's see, when we multiply these two together, we're going to get 9 minus I squared. So this xi and this xi, those guys are going to just cancel out. I squared becomes positive 1, so we're left with x squared minus 6x from our two terms, and plus 10 as our result. If you need to pause for a moment and fill in the in-between step that leads me from 9 minus I squared to 10, please do so. So what do I do with this? Well, this means that x squared minus 6x plus 10 must be a factor of p of x, and so I should divide x squared minus 6x plus 10 into my polynomial p of x here. So plus 10, that's going to go into, let's see, x to the fifth minus 8x to the fourth plus 13x squared plus 52, 13x cubed, pardon me, that's a cube here, and it is 52x squared minus 198x plus 180. All right, let's see what we get here. We know that x squared has to be multiplied by x cubed to get x to the fifth. So we're going to put 1x cubed here. That's going to give us x to the fifth minus 6x to the fourth plus 10x cubed. So we're going to subtract those out. What are we left with? Well, this is going to be negative 2x to the fourth plus 3x cubed. And I'll bring down the 52x squared. So we have to multiply by negative 2 2x squared to get negative 2x to the fourth. Negative 2x squared times negative 6x becomes plus 12x cubed. Negative 2x squared times 10 is minus 20x squared. So let's subtract again. We're left with 0 fourth. If I have negative 2x to the fourth minus negative 2x to the fourth plus 12x cubed minus 20x squared, I subtract that away. Of course, I'm going to get 3x cubed minus 12x cubed. That gives me minus 9x cubed. 52x squared minus negative 20x squared gives me plus 72x squared. Then I bring down 198x minus 198x. Negative 9 is going to go first here, so negative 9x times x squared gives me negative 9x cubed. Negative 9 times 6x gives me plus 54x squared. Negative 9x times 10, that's negative 90x. So I'm going to subtract that quantity away. It will give me the difference between 72 and 54. 72 minus 54, bring down to 7, carry the 12, that's 18x squared. 198 minus 90, so that's minus 108x. Bring down the plus 180. And so that means multiply x squared by plus 18. There we go. 18 times x squared gives me 18x squared. Minus 18 times 6, that's 108x. And 18 times 10, that's plus 180. And of course, when we subtract that away, we're left with 0 as our remainder. And so our polynomial now has the factor of x cubed minus 2x squared minus 9x plus 18. And we're interested in finding out where that's equal to 0. Well, this one can be factored directly by grouping. Notice that in the first two terms, if I factor out x squared, I'm left with x minus 2. And in the second, where I factor out minus 9, I'm left with x minus 2 again, equals 0. So this becomes the quantity x minus 2 times x squared minus 9. And we know where that one leads. X squared minus 9 is equal to 0 at x minus 3 times x plus 3. Where that equals 0, right? And we've got x minus 2 out here still. And so our zeros appear to be at x equals 2, at x equals 3, and at x equals negative 3. Well, that's just exactly the kind of thing that we were hoping to get right here. So our zeros, in addition to being our two complex numbers, 3 plus I and 3 minus I, are x equals 2, x equals 3, and x equals negative 3. And we're done.